Discussion on regression with just a couple of warnings, a couple of things to watch out for. The first of those is this idea of extrapolation. And extrapolation, you'll see, is using our line to make predictions for values outside the observed range of the x variable or explanatory variable. So I'm going to go a little bit corny on this one. Here's an example to see what we might mean by this. Suppose I've got some data, maybe on age of an individual and height of an individual. And maybe I've got ages, birth, up to 6 years old or something, and I've got data that looks kind of like this. So as they're getting older, they're growing taller. Then, what if I used the line to make a prediction for someone that's 80 years old? What would my line do so I only observed data between 0 and 6 years old. If I extrapolated that trend out much further, then that would predict the height of someone who's 80 years old to be, well, quite frankly, really, really, really tall. An impossible value here. So the idea behind this, we don't want to extrapolate because the trend may change outside of what we've observed. So maybe let's add a little comment here to that effect. Say extrapolation is dangerous. Is dangerous because the trend may change outside the observed values, as in this particular case. Okay, so extrapolation, using the line to make a prediction outside of what you've observed, and not a great idea because you don't know if the trend stays the same or if in fact it changes outside that range. Sorry, I couldn't help myself. Had a couple of corny comics to that regard down here. I'll let you peruse those at your leisure. Let's take a look at our last definition that we need to be careful about. And this is the idea of influential observations. So influential observations, we need to have two things happen for something to be an influential observation. The first thing is the x value needs to be relatively low or high compared to the rest of the data. And the second thing, it needs to not fit the overall trend. So I'll do a couple of examples off to the side here. This guy, suppose I have data like this. This point would definitely be an outlier in the x direction, but it would not be influential because it fits with the overall trend of the data. If I drew the line, it'd basically be the same with or without it. So this one is an outlier, really large x compared to the rest. And then something like this might be outlier and does not fit the pattern. So that would mean this is an influential observation. Okay, and the reason it's influential, if you think about it, if I fit the regression line without the point, it would look like this. If I fit the regression line with the point, it's going to be drawn towards that value or influenced by that observation and pulled closer to that value. So influential observations have a lot of influence on the mathematics of the line, and the line is pulled in that direction. Should sound familiar. It's not a resistant calculation, these regression calculations, easily influenced by these extreme observations. So here's just a real example. I pulled this from a paper in political science, and unfortunately they were making all kinds of conclusions with this paper. You'll notice their R squared is kind of on the smaller side, but you'll notice our country is definitely an influential observation. The whole reason the line is being pulled this direction is because of our country. If we weren't here, it would basically be a flat line with no real relationship between these two variables among the countries. So be very careful that you're not basing conclusions on a particular observation that is influencing your regression line.